Hi, in this video we're going to find an unknown angle in a diagram involving two triangles with a shared length. Now we've got this triangle on the left here and we're trying to find this angle, but we only know one of the sides, so we don't yet have enough information to work out that angle. But the triangle on the right, this one here, we've got this 10 centimetre side, we've got this 6 centimetre side, and because we know two of the three sides of this right angle triangle, we could find the third one. Now, what rule do you know that connects the three side lengths of a right angle triangle? Well, it's Pythagoras theorem, isn't it? So therefore, in this triangle, if I just draw it out separately, we've got the 10 centimetres here, and we've got the 6 at the bottom, and we want to find that height here. Let's just call it x because we don't know it. And remember how Pythagoras theorem works. You label the two shorter sides as a and b, either way round, and you label the hypotenuse as c, like this. And then Pythagoras theorem states that a squared plus b squared is equal to c squared, like that. So let's just substitute into that formula. We've got a squared, which is x squared, plus b squared, which is 6 squared, is equal to c squared, which is 10 squared. And now let's just simplify. We've got x squared plus 36 equals 100. Now we want to get x on its own, so we can subtract 36 from both sides to get 64 here. And then to get rid of the squared, we square root both sides to get x is equal to 8. So we've worked out that x is 8, and that's the x here. So that's the 8 centimetre length. And now we do have enough information to work out the y here. So let's just draw this triangle out separately. So we've got the 8 and the 7, and we're trying to work out this y. Now, this time, if we have two side lengths involved and the angle, we can use trigonometry. And remember how we do it. We first label these sides relative to the angle of interest. The angle of interest is just the marked angle that's not the right angle. So this is the angle of interest. And then let's label the two sides. So this side here is opposite this angle. So we label it as O for opposite. And this side here is adjacent to that angle. It's next to the angle. Adjacent to just means next to. So that's the adjacent. And we didn't use this side, but this is the hypotenuse. It's the longest length of the triangle, which we label as h. Now we've got O and A. So we look at our trigonometric ratios as we did before. And what involves O and A? O and A is this one, which is tan of theta. So we're going to write that formula. Tan of theta is O over A. And what's the theta? The theta is the angle of interest here. So it's this here. So let's just sub into that formula. We've got tan of the angle of interest, which is y, is equal to O, which is 7, over A, which is 8. Now, in the previous video, we saw that if you want to solve an equation like this to find out y, we need to get rid of this trigonometric function on the front. How do you get rid of the tan? Now, you can't divide by tan. Tan's not a quantity, but we can do inverse tan to get rid of it. And inverse tan is just basically something that undoes the tan. It does the opposite of tan. So we're going to do inverse tan of both sides. And we write that as tan to the minus 1, like this. So the left-hand side, the inverse tan just cancels out the tan. You're just left with y. And then the right-hand side, we're going to do inverse tan of 7/8, like this. And to get inverse tan in your calculator, you just do shift tan. And then I do 7 over 8. And that's going to give me 41.2 degrees. So let's put that in. Is it to one decimal place? Yes, it is. 41.2 degrees is the answer. And we're done.